Welcome. In this session, we will learn how to take Laplace transform in Matlab. Let's start our Matlab. So this is Matlab. Now to determine the Laplace transform of any function in Matlab uses the symbolic toolbox. Now what do we mean by this? Means we inform the Matlab that the variable or any function is used as a symbol as compared to the array. For example, the function used is sims. If I say sims t, this will inform that Matlab that t is a symbolic variable. It's not an array, so our ordinary variable. So if I say f is sine of t, so this is my function. So this is my function. F is a function. Now to determine the Laplace transform of this sine of t, I say LAC Laplace of f. This will give me the Laplace transform of this sine of t. You can see the Laplace transform of sine of t is 1 by s square plus this. Same way I can define the Laplace transform directly, just writing sine, for example, 5t. So if I say sine t, t is already defined as a symbolic variable, so this will give me the Laplace transform of sine of 5t. So this is a Laplace transform of sine 5t. Same way we can determine the Laplace transform of cos t, simply cos of, let's suppose, 2t. So the Laplace transform of this is s divided by s square plus 4. So this is how we determine the Laplace transform of these trigonometric functions. Now same way we can determine the Laplace transform of if I say t, simply Laplace transform of t is sorry, this is, I typed it wrong. This is Laplace transform of Laplace of t is 1 by s square. Same way we can say Laplace transform of, for example, t raised to 5 is 120. We know the Laplace transform of t raised to n is is gamma n divided by s square. So Laplace, to illustrate this, we know the Laplace transform of t raised to n is same as gamma n divided by s is 1. So the Laplace, now gamma n is, if n is integer, it will be n factorial. So if n is integer, gamma n factorial. So Laplace transform of 5 is simply gamma 5 and raised by 5 plus 1 is 6. So gamma 5 is same as 5 factorial and 6 is by 6. And we know 5 factorial is 120 raised by 6. So this is how we determine the Laplace transform in Matlab of these functions. So let me switch back to Matlab. Same way we can determine the Laplace transform of, let's suppose, square root of t. Laplace transform of square root of t is 1 by 2 pi raised by 1 by 2 means under root. This is 1 by under root of 2 pi and s cube, s raised by 3 by 2. So this is how we determine the Laplace transform of these functions. Same we can determine the Laplace transform of impulse function. We know the Laplace transform of impulse function is 1. So Laplace of 1. Now Dirac, this delta function is in Matlab is written as Dirac. And if I say Dirac t, this means delta t simply. Dirac t means delta t. So this will give me the Laplace transform of delta t. Laplace transform of delta t is 1. Same way we can use the shifted versions of this Dirac function means delta t. This is delta t minus 1. Laplace transform of this is e to the power of minus s. Same way we can say Laplace transform of delta t minus 5 is e to the power of minus 5s. Now Laplace transform of unit step function. Unit step means is written as Heaviside in Matlab. which is also called as Heaviside function, and it's written as Heaviside in MATLAB. So Heaviside t means u of t simply. So this will give me the Laplace transform of u of t. Same way you can say the Laplace transform of shifted versions of this unit step function means u of t minus 1 is e to the power of minus s divided by s. Laplace transform of this u of t minus 5 is e to the power of minus 5s divided by s. Same way you can say Laplace transform of u of t plus 5 is this. All right, so this is the Laplace transform of a unit step function. And same way you can determine the Laplace transform of other functions as well. See, if you use in general, so if we say inform MATLAB that a is a symbolic variable, then you can say Laplace transform of cos of at also. At. So this will give you the Laplace transform of a of t. Laplace transform of a of t is s divided by a square plus s square. We know this already from the maths class. So this is how we determine the Laplace transform of any function. Now, if we have to determine the inverse Laplace transform of this function, for example, if I say sims s, I'm saying s is used as a symbolic variable. Now, if I want to determine the Laplace inverse Laplace transform, the function is I Laplace. I Laplace means simply inverse Laplace transform. Let me take this example that I solved just. So s square plus a square. Let me see. With this I determine just. So this is simply cos of at. Same way Laplace transform, inverse Laplace transform of, let's suppose 1 by s cubed. 1 by s cubed, this should be 1 by 2 t square. The inverse Laplace transform should be t square by 2, I guess, yes. This is t square by 2. So this is how we determine Laplace transform in MATLAB of any function. Solve other examples yourself, you will get the answer. All right, let me stop it here. In the next session, we'll do how to write the transfer function in MATLAB. In the next session, we'll do how to write the transfer function in MATLAB. Okay, let me stop here.